Alright, we are continuing with 4.6, which is dealing with other trig functions. And right now it says find each value. Make sure you have access to this table right here. You'll notice all of these have what? Capital letters. It's something you need to be aware of. Whenever you see a capital letter, I'm going to go up here. We're going to look at something. It says capital letters are used to distinguish the function with restricted domains from the usual trig function. So we're going to be restricting their domains, okay? And when you guys look at this, when you see arc sine, I want you guys to think of the inverse of sine. When you see arc cosine, I want you to think of the inverse of cosine. And lastly, when you see arc tangent, I want you to think of the inverse of tangent. Okay? So make sure that you guys aren't confused about what it's asking you to find. Okay? So you could write notes on the notes that you have in your journal. All right, let me go back to this one right here. The very first thing that I would like you to do is I would like you to draw a unit circle. You're going to draw a unit circle. When you draw a unit circle, there's certain parts that you just need to be aware of. So we're just going to label certain things. This right here is at 0 pi. This right here is at pi over 2. This here is at pi. And this is at 3 pi over 2. I'm also going to write, or you could actually call this negative pi over 2. If you guys see a capital A, let's look at the domain. And the range of this particular arc cosine. Go over here and look at it. We have arc cosine. What's the domain? Between a 1 and a negative 1. And what's the range? Between 0 and pi. Okay, so right now, we'll go back over here. I want you to write it. My x values are between a 1 and a negative 1. And my range, my y values, are between what? Pi and 0. Let me explain to you this part. What does that part right there mean? That means that if I go from 0 all the way, bless you, all the way to pi, that's talking about this part right here on the unit circle. So my answers right here, my answers are either going to be in quadrant 1 or they're going to be in quadrant 2. It's either in quadrant 1 or quadrant 2, because this is from what? This is from 0 to pi. So right now, what would be my ordered pair right there in a unit circle? This would be at a 1, 0. What's my ordered pair right here? 0, 1, right? And what's my ordered pair right there? Negative 1, 0. Now, when you guys are looking for what's called the inverse of cosine of negative 1, does anybody remember what cosine of theta always compares? If you look back at your chapter 4, section 3, dealing with your trig ratios, because we're going to rewrite them real quick so you can know. You got sine, you have cosine, and you have tangent. The 3 basic trig ratios. So sine compares your y value to your r value, cosine compares your x value to your r value, and tangent compares your y value to your x value. Another thing that everybody needs to be aware of is x squared plus y squared will always equal your r squared, which is still is what? The whole a squared plus b squared equals c squared. So this is a formula when you have x and y, you can find r. Or if you have r and y, you can find x. So you need to know these three. You also need to know this formula. Okay? So right now, I'm going to compare x to r. And I'm going to highlight this portion right here. My ratio has to be -1 to a +1 because your radius always has to be positive. That's why I know my radius is a 1 and my x value is a -1. So I paused the video. I'm not sure exactly where I left off. Okay, so if you're listening to this, you're like, dude, you already talked about that. So right now, we know our r value is going to be positive. Our x value is a what? -1. So I'm going to go over here and I'm going to check. Where's my x value right here? 1. That's not it. What's my x value here? That's not it. What's my x value here? Ooh, that's it. So, right now, where am I at when I'm at a -1 to a 1 ratio? I'm at the value of pi. Therefore, my final answer is pi. Now, basically, I'm at what? On the unit circle, I'm at 180 degrees, but 180 degrees means pi. So you would write, the answer is pi radians. Okay? So right now, I'm going to go to my graphing calculator and make sure your mode is in radian mode. Okay? And I'm going to hit second cosine, which is arc cosine. And I'm going to type in a -1, like that. And I'm going to hit enter. Now, I'm not sure if you guys are very familiar with the value of pi, but if you type in pi, and press enter, there is an approximate value. And you'll notice that the cosine, by the way, all I did was change it from what? Arc cosine of -1. So what is the arc cosine of -1 actually equal to? Pi. Okay? So that is the answer to, hopefully you guys realize, we're right here. These right here, they are the same. So we're going to go ahead. By the way, this is going to be very important. We have to use this to help us know what we're going to be doing within the unit circle. So on the next problem, make sure you are using this. So here we go. Next problem, moving on. Oh man, I got to go all the way back up here. I apologize. You can fast forward me until you see. Aha! Problem number 4. So here we go. Problem number 4. Step 1. What am I going to draw, everybody? That's right. I realize this is not easy, so I'm trying to give you guys a process that you can do every single time, so your brains don't explode. All right, so you don't think about hurting yourself. That'd be bad, or hurting others. Okay. So right now, is that up and down? No, that's not bad. A little bit off. I know. I just can't. Forget it. That's good enough. All right. So right now, label this as pi over 2. Label this as negative pi over 2. And label this as 0 pi. Now understand, negative pi over 2 and positive pi over 2. So that's 90 degrees, right? This right here is 90 degrees. This is also considered to be 3 pi over 2, so I'll put 4. Okay, so right now, we have, it's a capital letter, so we have a restricted domain, okay? So what is our restricted domain? What is our domain? All real numbers? Sweet. So it's not too restricted. However, our range is restricted. What is our range restricted to? Okay. If you're wondering, where in the world did you get these numbers? I'm going to go back. Right here. So right now we're dealing with, there's our domain, all real numbers. We're going from pi over 2 to negative pi over 2. So let me show you where that is on our unit circle. Here we go. This area of the unit circle is where your answers could be located in this graph, okay? So here's what we have. We are saying the arctangent of what number? 1. So you either are going to be in quadrant number 4 or you're going to be in quadrant number 1. Now, tell me about your values for x and y in quadrant 1. They're all positive. However, over here, your x values are positive, but your y values are negative, okay? But what does the tangent of theta, what does that always compare? What values is it comparing? Y over x. So we need to be comparing values that are y over x. 1 over 1. So I want you guys to understand, yes, we're going to be doing the arctangent, okay? We're going to be finding the, but right now we're still comparing a 1 over a 1. So right now, the only place where a 1 and a 1 is, if I put a 1 and a 1, this is what would be built in your unit circle. It would go over 1 and up 1. So what kind of triangle is built right here? It's a 45, 45. So this triangle right in here is a 45, 45, 90. So right now I'm going to label the size of my right triangle. The x value is equal to 1. My y value is equal to 1. My radius is going to be a radical 2 in this particular case. So I'm at a 45 degree angle. This is where I'm located. So if I said, what's the arctangent of 1? Which basically means, what is the inverse of this? How many degrees did it end up becoming? 45 degrees, because we're dealing with the 45, 45, 90. But how can I convert that 45 degrees to radians? What am I going to have to do to convert the degrees to radians? That one. Pi over 180. So take 45 degrees, multiply it by pi over 180 degrees, and that will convert it to radians. So in the calculator, you can just do 45 over 180, and that reduces to pi over 4. And your answer is pi over 4 radians for this problem. Okay? So what I'm going to do right now is I'm going to go over step by step what we did. Step 1, draw a unit circle. Step 2, look at your trig ratio and know which numbers you're comparing. We compared what? Y over x. What did these have to equal? They had to equal a positive 1. Why could it not be in the fourth quadrant? Because our y value is negative and our x value is positive. So when you have a negative divided by a positive, your answer wouldn't be a positive 1, it would be a negative 1. So I know I have to be in the first quadrant. Then what did I do? It has to go over 1 and up 1, which means what kind of triangle did you have to build? A 45, 45, 90, because that meets the properties of a 45, 45, 90. So once I knew it was 45 degrees, I wanted to convert it to radians, so I took the 45 degrees and multiplied it by pi over 180, which reduces to pi over 4. I realize it's a lot for you all to take in, but you can always check your answers. Watch. If you get an answer, and you think the answer is pi divided by 4, and you press enter, you see that decimal? Sorry? No. They're right there. That's pi over 4. Now check this out. If I said second tangent, and what number did I want to find the inverse of? 1, and you press enter, what should it equal if you're right? The same. So this is how you, hopefully, you guys are picking up what I'm putting down here, that you can check your answers. If you find the right answer in radians, which is this decimal, and then in the calculator, what did I do? I basically found what? The arc tangent of what? 1, because these mean the same thing. Then you can check this decimal to this decimal. So once you get an answer, what do I want you to do? Check it. So if you want to start this problem, it says the arc sine of 1/2. If you wanted to start, like, okay, what do I got to find? The second sine, I'm going to do -1 divided by 2. So at the very end, what should my answer be equal to? This. Whatever this is. I know what it is, but you need to find that. Okay? That's what I want you to do next. So go ahead. Try to do the next one on your own. We will check it in 5 minutes. So we're just going to pretend it's been 5 minutes. Okay? So the very first thing we're going to do is I'm going to draw you the circle. And hopefully this will be better than my last one. Alright, because my last one stunk. It is. I have deviated second. I don't know why. God, I do it. So, right now, I'm going to write domain and range. Did anybody happen to look up the domain and the range for this?
Yeah, it's -1 to 1 for the domain.
Okay, -1 to 1.
No, that's 1.
Oh, you're right. Here. See, I knew it was 1, right? There we go.
And then the range is -π/2.
Alright, so here we go. Now, what this is letting me know right here, it's letting me know that my answers are between here and here. Okay? So, this right here is at π/2, this right here is at -π/2, right here I'm at 0 pi. So I know I'm either going to be in quadrant number 1, or I'm going to be in quadrant number 4. But this negative sign basically gives it away of which quadrant you're going to be in. Okay? Now, if this was positive, I would know I would be in quadrant 1. But being that this is negative, I know I have to be in quadrant number 4. So remember, the sine of theta always compares the y value to the r value. So if my r value is always positive, I know my r value is 2. And my y value is -1. Now, I don't know if anybody did this, but I'm just going to go ahead and do it anyways. X squared plus y squared equals r squared. And I'm going to find what my x is, even though I already know what it is. What is my y value? -1. I'm going to square it. What is my r value? 2. And I'm going to square it. So I get x squared plus a 1 equals a 4. Subtract 1 from both sides. X squared equals 3. What does x have to equal? The square root of 3. Technically plus or minus, but I know I'm dealing with the right triangle, so I don't deal with the square root of 3. So here's what I want you to build. We're going to build a triangle. Okay? We're going to build a triangle. And I know my triangle has to have a radius of 2. This side is a 1. This side is radical 3. So right now, this is my 60 degree. This is my 30 degree. This is my 90 degree. So the properties that you need to have in your journal are of a 30, 60, 90, or x. X, radical 3, and a 2x. This is something you need to have access to. So all I'm going to do is put a 1 radical 3, and a 2. This is the most commonly tested right triangle in all of high school. All right? Like SAT, ACT, they use the 30, 60, 90 more than they use the 45, 25. Okay? They use this all the time. Now, right now, what is ours? Ours is a what? -1 over a 2. So right now, I'm going to take this triangle and I'm going to put it in our unit circle. So I'm going to go over a certain amount, I'm going to go down a certain amount, and I'm going to create a right triangle where here, this is radical 3, this is -1, this is a -1, and this is a 2. And if this right here, everybody, this is theta, okay? And sine represents my y value in comparison to my r value. What's the ordered pair that goes here? The ordered pair is a radical 3, negative 1. My x is radical 3. My y is negative 1. My r value is a 2. What did we compare? We said our y value was a negative 1 to a 2. So what does this angle right here have to be? Going down. What angle, what number is always across from 30? A 1. So what does this theta have to be? 30. Except I'm going to call it negative 30 because from here it goes down. And whenever you go clockwise down, that means your angle is going to be negative. Whenever you're going clockwise, it's negative. Counterclockwise is positive. If it was in quadrant 1, my answer would be positive 30. But how do I change this to radians? Multiply it by what? Pi over 180, and your final answer is negative pi over 6 radians. Negative pi over 6 radians is your final answer for problem number 5. If you wanted to check it, check this out. I'm going to do negative pi divided by 6, and hopefully you'll see that these right here are the same.